Hi everyone, it's a pleasure to meet you in this video. I am Ramadas, an assistant professor AC department. I hope this video will help you an idea about overview of DSP. By the end of this video, you will know how to deal with some basic DSP questions. Before entering into this video, you must know why we need DSP. So DSP is important because it provides the flexibility of using the same digital hardware for many different applications. Before DSP, different analog electronics would be required for different applications. Now, for example, your smartphone. Your smartphone is everything from your cell phone, radio, camera, navigation tool, music players, video players, or so many social apps are installed in your same hardware. All are using the same hardware only as a result of DSP. So, because our digital signal do not produce noise, that's why we move on to DSP. In this video, what we are about to learn is, first thing is signals and system review, then introduction to DSP, then in the third part I will talk about techniques, what are the techniques used in DSP processor. In the fourth part I will talk about advantages of DSP when compared to that analog signal processing. My fifth part I will talk about disadvantages of DSP over the ASP processor. Finally, I will go on talk about some DSP applications with examples. So what is signals? Signals means that the thing that carry the some information is called as signal, or it convey the some information. For example, if you take ECG signal, ECG means electrocardiogram signal that provide the information about the health of a person heart. ECG, it provide the information. So that's why we call it ECG is also one kind of signals. So it provide the information, it convey the information. Now you understand what is signal. I will give one more example, EEG, electroencephalogram, that provide the information about the brain activity of a person. So look at this definition. A function of one or more independent variables which contains some information, we call it as signals. So based upon the time, it can be classified into two types. One is analog signal and another one is digital signal. Next we move on to system. A system is a set of elements or functional blocks that are connected together to produce the output in response to your given input of the system. This is called system. So simply you can say system means it will give the meaningful interconnection of physical device and the components. For example, any system, it can process your input signal and it can produce the output signal. Those output is respond to your given input signal. We call it a system. So here also based upon the time, you can classify it into two types. One is continuous system and another one is discrete time systems. I will give you some example for analog signal and digital signal. Analog signals, most of the signals are in analog in nature only. For example, sound signal, video signals, temperature signals, pressure, seismic signals, biomedical signals, this are all analog signal. Discrete time signals means speed of the vehicle at certain interval. So this is what the example for digital signal. Now we move on to introduction to DSP. Here I split up this term into three different terms. One is digital, then plus signal, plus processing, which may equal to digital signal processing. So what is digital? So digital means there is a discontinuous representation of the signals. Example, our computers, digital phones, digital pens, etc. This and all we call it as digital. So simply you can say digital means the signal that are discrete in time and quantized in amplitude are called digital signal. Next we move on to signal. Signal, as I said earlier, signal it conveys some information. Processing means a series of operation performed according to the programmed instruction. Whatever we programmed already in your system, so based upon the instruction, our system can be processing your signal and it can produce the output signals. What is DSP? DSP is the mathematical manipulation of an information signal. Mathematical manipulation of an information signal such as audio, temperature, voice and video. Here our DSP processor can modifying the signal and also it can improving the signal in some manner. That is what we call it as DSP. Look at the definition. DSP is the process of analyzing and modifying a signal to optimizing or improve its efficiency or performance. So what main role of DSP is, DSP provide the high quality signals and it reduce the noise, it suppress the distortion. So that's why we go for DSP processor. What are the techniques we used in the DSP processor? You just see in this next slide. Before that, I'll give some examples for DSP processor. Here DSP processor can be used in speech coding, transmission in digital mobile phones, room connection of sounds in hi-fi and sound reinforcement applications, weather forecasting, economic forecasting, seismic data processing, medical imaging. These and all the example for DSP processor. Now we move on to techniques. What are the techniques we use in DSP processor? Here I will give some techniques only. Other than that, we have so many techniques are available. So first you look at, see here, first BLT. BLT means bilinear transformation techniques are used in our DSP processor. Then DFT and DTFT. DFT means discrete Fourier transform. DTFT, discrete time Fourier transform. Then Z transform, filter design. You may design any kind of filters, maybe IR filter or FER filter. Then Goertzel algorithm, LTA system theory, linear time invariant system theory, minimum phase, S-plane and transfer function. So these are the techniques we are used in our DSP processor. So what are the advantages of DSP processor? Before entering into these advantages, you must know about the how the signal processing can be classified. What is signal processing? Signal processing is the operation that changes its characteristics of a signal. Here the characteristics means amplitude of the signal or phase of the signal or shape of the signal or any frequency content of the signals. So signal processing is the operation that changes its characteristic of a signal. So there are two different types of signal. One is analog signal processing and another one is digital signal processing. Now I will give the advantages of DSP processor. So these advantages are when compared to our ASP processor only, analog signal processing only. First one is flexibility. Why I say here DSP processor is more flexible when compared to the ASP means, here you can simply change the software program. If you want to modify or reconfigure your system means, you can simply change the software program, it's enough. So DSP processor is more flexible. Next thing is accuracy. DSP processors have more accuracy when compared to that ASP, because ASP signal processor, it can face some component tolerance problem and breakdown problems, etc. Then DSP processor is easily storage media, because defaultly DSP processor, it can have some storage media such as magnet tapes, disk, etc. But in ASP processor, it can face the storage problems. So that's why DSP processor have easy storage. Then mathematical operation. Yeah, mathematical operation can be accurately performed in digital signals when compared to that analog signals. Next, cost wise it's very cheap when compared to that ASP. Then it is more flexible and more reliable. Size is also very compact. Then disadvantages. What are the disadvantages are found in DSP means, it is very difficult to process high bandwidth of analog signal. When the bandwidth of high bandwidth of signal means, we need high speed AD converters are required, but our high speed AD converters are difficult to achieve for same signals. So this is the main drawbacks of DSP. Then cost wise expensive. It is more expensive for small application, because when complexity application, DSP processor is very cheap, but for small application also it can get the same cost only. So expensive wise, it's very one of the disadvantage of DSP processor. Then application of DSP processor. What where and all used our DSP processor. First, I would like to say about DSP for voice and speech. So this is the first application of DSP processor. I would like to explain here. First, voice and speech. Here, our DSP processor can play a major role here, played in here. Because if you want to recognize your speech signal, if you want to enhance your speech signal, if you want to synthesize your speech signal, or if you want to convert your speech to text or text to speech, so this and all we used here. Next thing is telecommunication. Telecommunication, you all know about that, because nowadays telecommunication plays a vital role in our life, isn't it? So we can use the cellular phone, speaker phone, digital speech interpolation, video conferencing, spread spectrum communications, or any more multiplexing, channel multiplexing, data encryptions. So this and all we use it in telecommunication side. Consumer applications, here we can use the digital audio, video mixer, or music composer, or music synthesizer. Even toys also comes under the consumer application. Military and defense, we can use the secure communications for using military. Defense side, you can using the radar processing and sonar processing, missiles guidance. This under comes under military and defense. Biomedical, you all know about that, X-ray signals, ECG, EEG, or some hearing aids, or patient monitoring system, or if you want to diagnostic the tools, this and all comes under biomedical engineering. Graphics and imaging means you can use the 2D graph or 3D graph, visualization, animation works and all done here. Then control application. If you want to control your robot or any industry control or voice command, if you give the voice command, so we can use here. So finally,